Hi. So what I thought I'd do is I'd do a analysis of the transistor challenge that we had, the first one. It piqued my interest when we had different voltages, right? So here we have Tinkercad, and Tinkercad says the base voltage is 3.38 volts, says the emitter voltage is 2.76, and our collector is 5.4 volts. Now when I switch over to Electronic Workbench, it says the base voltage is 3.34 volts. The emitter voltage is 2.579, 2.58, and our collector is 5.6. So I thought, well, let's see what our predictions do. So I made a little table, and in the table we have our base voltage for Tinkercad was 3.38, Electronic Workbench was 3.42, and our prediction is 3.78 volts. So our prediction is a little bit on the high side, and if we actually do a comparison and we say 3.78 divided by 3.38, we'll find out we're about 12% high. Now, the reason that we're 12% high is because, let me just show you here, is we take an approximation. This is the formula that you would use to calculate what the base resistance is. We do something that's called R prime E, which we haven't really talked about, is that in the base of a transistor, there's a, let's see, we'll get over to here. On the base of a transistor here, there is an impedance. It's called R prime E, and it's determined by the amount of current that's flowing through here plus the beta of the transistor and the effect of this resistor. So this forms like a parallel resistance with this one. We ignore that because normally it's roughly around 10%. It'll affect this by about 10%. So we can ignore that, which makes our calculations very easy because we don't have to do this mess, right? This is no fun at all. You have to take the voltage at the base minus VBE divided by the current, which we don't know yet, times it minus the emitter resistor times by beta, then you get the effective input resistance, which this part here is called R prime E. In our world, we don't need to know that. What we'd find out that if we measured a circuit and the circuit says it should be 3.38 volts and we measure 3.78 volts, that's perfectly fine. Now, something else that was interesting was VBE. So the base emitter voltage for Tinkercad, they said for that transistor was 0.62 volts. EWB was 0.763. So right off the bat, the simulations don't agree on what voltage is. And we just used our default of 0.7 volts for our base emitter voltage. Naturally, if you have different voltages here, it's going to affect our emitter voltage because we just take our base voltage, subtract our base emitter voltage, and we get our emitter voltage. So right off the bat, we have inconsistencies. And because we've now got inconsistencies on our emitter voltage, that's going to change our emitter current, which is our collector current, and it's going to affect the calculations for our collector voltage. So that's all I want to mention was the differences and why. So if you're wondering why, if you tried to predict them, your voltages did not match what was measured, we can see that typically in electronics, everything is sort of by golly, is the phrase we like to use. All right, thank you.